Today, we are here with Mr. Paul Robichaux as our presenter. We are very excited to put on this presentation for you today and appreciate the time that you are spending with us. We know your time is valuable, and we are very happy that you are able to make the time to come out and see the information on our IPL check. It is going to be some really great information, so stay tuned for our webinar coming up now. Avoid ZOS, IPL surprises, reduce risk, gain control with IPLCheck. And with that, Paul, if you want to take over, I'm going to hand it over to you.
Okay, thank you very much, Sammy. I appreciate you setting this up and welcome everyone, those of you in the United States and around the world. I personally am located in Northern California and really thankful that you decided to spend a portion of your day with us. Of course, you're here because you responded to an invite that was sent by Share that essentially said, look, there's something kind of cool going on with something called IPLCheck from NewEra Software. And our agenda today is essentially to offer you some better understanding of what the NewEra product offering is, to talk to you about what we refer to as AI for system programmers, a fact-based way of being able to analyze the IPL path very quickly and with great detail. And then we're going to explain away what might be some confusion in your mind about the relationship between image focus and IPL check. And then once we're done with that, which should take about 10 minutes, we're going to go into a direct IPL check demonstration and use both SDSF and ICE Direct in order to more elaborate on the content of the information that becomes available in what we call the inspection log. But as I begin this, I think the summation of the value of both image focus and and IPL check is encapsulated in this quote from Bob Rogers. System programming, what is it? It's a big, complex job with lots to do and lots to be held accountable for. I can't imagine a better definition. There's just so much dependent on the quality of the service that you provide to the ZOS community of your organization, and the accuracy and the sustainability, and not only the security, but the integrity of the ZOS environment often rests in your hands. So thanks for that. Good job. Well done. All right, so let's just talk briefly about NewEra's product offering. As you can see, the product names on the left-hand side. SAE, the standalone environment used to recover a failed IPL. Fast erase, a method for erasing data at the end of a disaster recovery test. What's totally unique about both of those tools, SAE and fast erase, is that they run on bare metal. They don't need an operating system in order to be able to provide their functionality. A 3270-like editing environment in the case of SAE, and the fastest erase possible of DASD at the end of a disaster recovery site. Image focus, something we're well known for, that incorporates a number of different segmented tools. IPL check at the top of the list, image check, which is the full image focus, along with a sysplex check, and importantly, new release analysis, a tool that's going to become incredibly important as we approach the release of 3.2. Subsystem inspectors, JES, VTAM, TCP/IP, a plethora of IPsec components like OMP route and FTP, and specifically Pageant and all of its components, IPsec, ATTLS, etc. Supplemental inspectors, of course, the control editor, and our web-based interface to the outputs from image focus and the control editor we refer to as ICE Direct. The application of them across the spectrum of system programming responsibilities includes both ZOS integrity and ZOS security. We can help you in prepping for an IPL, We can help you in establishing the infrastructure that's necessary to implement validated boot. We can help you post IPL with recovery and monitoring and an analysis of secure boot, the product of validated boot, and related analytics. On the security side, we offer a number of different access rule methods, including multi-factor authentication for supporting access to the ZOS environment. And on the control side, that is, once the systems are up and running and we're inside the perimeter, change access, change controls, access rules, dynamic capabilities, backups, event logs, and importantly, zero trust. So a full spectrum of tools, not just image focus or IPLCheck, but a full set that can be applied across the spectrum of ZOS system programming responsibilities. Now, one of the core features of our offering, particularly in image focus and IPLCheck, is what we refer to as the inspection platform. It is essentially AI for system programmers. Through a process of supervised learning, our data scientists use formal documentation, new PTFs, experience from both customers and their own knowledge, essentially to train a rule stack that is able to analyze the IPL path of a ZOS environment. Any ZOS environment from version 2 on through 3.1 currently, and soon, of course, with same-day support for 3.2. The idea here is to provide an assistant for making sure that your work is checked and rechecked and monitored on a continuous basis to make sure that nothing is creeping in that may result in some sort of a finding that might prevent or cause an outage in your ZOS system. All of the results from the model can be analyzed through exploratory data analysis because all the details of what it has done are included in an inspection log data set, sometimes referred to as a prediction data set. This data set contains information that is fact-based and transparent, though it becomes obvious very quickly in an examination of the IPL path what potential problems may exist. We classify them as, to degree, as errors, warnings, notices, and informational. But there are often discussions with users about our default classification, and quite frequently, they prefer to provide their own filter rules, highlighted here in red. And once those filter rules become incorporated into the model's training, they, on a site-by-site, user-specific basis, begin modifications of the model's understanding of what you want it to report as an error, a warning, a notice, or informational. Of course, to use it, like any AI, we need to prompt it. And the prompt can be as simple as asking it to automatically discover the unit address and load parm of a specific ZOS instance. And that's the way it works when we're talking about IPLCheck. But we can also use it in other ways and be specific about the unit address, load parm, and other characteristics like the analytic scope of the inspection log in being able not only to look at the running system, but also able to look at any system in a sysplex or any system that might be under development and not even a running system at any particular point in time. So it's quite flexible. Its prompting is quite dynamic and quite detailed. And once it's prompt, it's on its way to perform a complete analysis of the IPL path, including not only ZOS, but subsystems like JES, VTAM, TCP/IP, CICS, etc. Now, I know AI is on the minds of everybody now at this point, And so I thought I'd include a couple of slides here that we could explain in more detail if you're interested in hearing the story as to where we position image focus on the spectrum of potential AIs from weaker to stronger. And so if that's something that would be of interest to you, let us know. We'd be happy to talk more about it. And here's an actual definition, an AI definition of what the inspection platform is. It is referred to as a rule-based retrieval AI model, essentially meaning that it has a rule stack and an interface to some dynamic environment, in our case, the ZOS environment, for retrieving information and applying the rule set against the information that has been retrieved. Again, if you want to talk more about this, we'd be willing and happy to do so. But specifically, when we talk about image focus and IPLCheck, there tends to be some confusion. So I want to be clear on this. IPLCheck is image focus, running exclusively under the control of the IBM Health Checker for ZOS, performing its inspection on the running system. It is a force multiplier, just like image focus is, and its whole intention is to provide information, in IPLCheck's case, not only about the current configuration params that are contained in ParmLab, but also any dynamic changes that might have taken place since the last IPL. Those dynamic changes to the APF list, the link list, the LPA list, BPX and BPX parms, the symbols, etc., are concerns because once those changes are made, usually by line command, they then begin to affect the operation of the real system, what is in its memory and what it thinks its instructions are. Those need to be hardened back into the actual configuration in order to make certain that in the event of an IPL, expected or not, that next IPL will actually bring back the system that was quiesced. So it's important to understand that IPLCheck is image focus, a force multiplier running directly under the IBM Health Checker for ZOS on the running system, looking not only at the IPL path and the configuration params in ParmLab, but also looking to identify any dynamic changes that may have taken place to the running params. Now, I think you'll agree once we get into a demonstration that the interface to IPLCheck is essentially a bit restricted. And that is that you can view it and its output under SDSF, or you can go to 3.4 and examine its inspection log. And our technical support team will be happy to give you some tips on how to quickly evaluate that inspection log. If you have 2, 3 systems, it's not a burden. You can simply go from one to the next to determine what is going on. But if you're in a larger environment, that is where you might have 10 systems under inspection under the IBM Health Checker for ZOS, it can become a real problem to be able to manage all of the insight that's necessary to understand what's being reported to you. An inspection log can sometimes range in size up to 10,000 records, some even larger, depending on the complexity of the ParmLab concatenation. The good news is that you can do exploratory data analysis of those logs under a tool we call ICEDirect. ICEDirect can consume those logs and display them in unique and interesting ways, and we'll get to that in just a moment. So the takeaway point, smaller systems, SDSF is likely to be found. But in a larger environment, you're going to need the help of ICEDirect to understand and explore and gain insight from all of the logs that are being created. Now, here's a view of what that might look like. SDSF on the left-hand side and ICEDirect on the right. You'll see on the left-hand side 2 two health checks that are being highlighted. One is called dynamic change inspection, and the other one is called OPSIS inspection. With IPLCheck, those are the two inspectors that you get access to. But you can also see all the other inspections or inspectors and the health checks related to them also detailed here, starting with the pageant demon, defense manager, all the way down to Telnet as a separate inspector and health check. So there's quite a large family of health checks that's available from NewEra software, but the two we're going to deal with today are dynamic change and the OPSIS inspector, which are available to you should you choose to acquire, excuse me, the product. Okay, so that takes us to the next page, which is just a reminder that ICE Direct is a web-based application, but it can be fully integrated into ZOSMF, and it is the recommended path that I like that gives us an incremental security, the kind of security that surrounds the ZOSMF environment. In addition, it also supports multi-factor authentication. And so it's possible that you could enhance the security of ICE Direct to a level that would require logging on to ZOSMF and the related security associated with that, and then subsequently have to re-authenticate yourself through multi-factor authentication before you could reach the ICE Direct logon panel. So with that, what I'm going to do now is switch screens here to have something that mirrors my slide. On the left-hand side, we have a ZOS environment. On the right-hand side, we have a web environment. And I'll just go ahead and begin on the left-hand side and bring you in and have a look at what IPLCheck is all about. So I'm logged on, and we're at the primary menu. And so now what I'm going to do is go to M.5. And here I'm in SDSF. I'm going to type CK on the command line to list the health checks. I'm going to do a find on NEZ. And we get no data. There's no, excuse me, NewEra Health Check running at this time. So now I'm going to go to ST, and I'm going to start IPLCheck. Now, remember this, I probably should have pointed this out on one of the slides that I kind of glossed over, but installing image focus is a relatively straightforward thing. And when you install it, you get IPLCheck. Now, from the IPLCheck alone perspective, if you install it in an environment that shares DASD with all the systems that you expect it to execute on, they can all share that same installation by simply making sure that their procs are appropriately configured so that you can start IPLCheck on all of the systems that you want to have managed. And again, if it's 2 or 3, that's probably pretty safe to be able to evaluate that. If you get into the 5 to 10, or certainly 10, in some cases our customers have up to 25, doing exploratory data analysis is going to require a tool like ICE Direct. So I'll go ahead and submit this. Okay, now it's running. Now, once you start it up, it's going to start on its own. It's going to register itself with the health checker. And then from that point forward, it's operating under the control of the health checker. And whatever configuration the health check have for this particular tool in this case, of course, IPLCheck. Now I'm going to do CK, and now I'm going to do a find on NEZ. And so here's our two checks that are running now at this point. You can see that the dynamic change inspector off to the right says its status is success. And you can see that the NEZ ops inspection status is an exception. Now, if I put an S next to them, this is the extent of the finding, excuse me, that we have for dynamic changes. And so the dynamic change analysis extends to the APF list, the BPX list, BPX parms, link list, LPA. We have a difference there between the configuration of LPA and what's actually being used, and of course the symbols. And so in order to be able to understand exactly what that means, we're going to have to go find the inspection log and do some analysis of it. As far as the OPSIS inspection is concerned, it's going to detail all of the warning, our errors, warnings, and notice messages that were produced during the inspection. I can find my key. And you can see in this case, there's quite a few of them, and most of them deal with inadequate protection of data sets. We not only check the viability of the data set, that is, does it exist, does it have the appropriate attributes, but we also check to make sure there's an appropriate profile to protect it, sort of a number one rule in establishing the integrity of your ZOS environment. So I'm on a little test system. It doesn't need that level of protection. It's isolated and only used by me, so you can see all the inadequacies here. Now what I'm going to do is I'm going to go to 3.4, and we have a log that has been created. The log names are dynamically created by the system, by IPLCheck, to include your high-level qualifier, and then our qualifier, IPLCheck, and then the actual name of the image or LPAR that's being inspected, in this case, SOW1, and then with the extension log. And if we select that, now you can see I selected edit, and it says the data set's in use. That is, once IPLCheck references and starts itself, it dynamically creates the log, and it reserves it for its own use. And so we can browse it, but we're not able to change it at this point in time or edit it. So here it is, and it's quite lengthy. If we max to the bottom here, in this case, this particular log is 7,094 lines or records long. And I'm not going to take you through the detail of this and its inspection of the IPL path, but we'll leave you with this. There are a number of different tricks and methods for exploring this directly in 3.4 and in Browse, and our technical support team will be able to provide you with that level of understanding. If you want that help, they're more than helpful or happy to provide it. I'll go back up to the top. Now what I'm going to do is I'm going to go over to the right-hand side and log on to IceDirect. Now remember, I said we could log on directly under ZOSMF. I'm getting to it from the World Wide Web, which is an alternative method for doing that. Typically, these links are supported by specific ports that have specific profiles associated with them, so not everybody can get in. And again, ZOSMF security, multi-factor authentication security, and port security can provide you with a highly secure ZOSMF, excuse me, with a highly secure ICE Direct environment. So I'm going to put in my user ID and my password and launch it. Okay. So now we are in ICE Direct, and what you see here is the initial welcome panel. It's welcoming me back because it knows I'm a user. If you were logging on for the first time, it would just say, welcome, thanks for using ICE Direct. There's a number of different tools and other things here that can provide assistance in understanding the opportunity that you have for exploratory data analysis. One of them is that we consistently, let me get this out of the way, we consistently provide video updates and park them on YouTube, and you can reach them by simply clicking on this little video icon here at the bottom. The geography of the panel is quite simple. On the left-hand side, we have what's called a sidebar. On the very top, as you'll see here as I select IPL, we have the request bar or the request frame. And then below that, we have what's referred to as the results frame. So if I click submit a request, now I've selected my IPL, so this is the interface for IPLCheck. What we're doing now is going out and discovering all the IPLCheck logs that are active in this particular system. And so we've done that now, and we've displayed what are referred to as frames. Each one of these, 1, 2, 3, 4, 5, is an individual frame. It operates independently of all the other frames and contains a dashboard of the results of the inspection that was conducted by IPLCheck. There's lots of information on the dashboard itself that's worthwhile paying some attention to. For example, it will tell you what is the date of the last IPL of this particular system. What is the date of the inspection log itself? What version of image focus was used to, or IPLCheck was actually used to create the log? And what is the date and time of the log? In addition, it will also provide you with an understanding of whether or not a personal baseline that you have established is still consistent by what we refer to as checkpoints. There's a ZOS checkpoint and there's an IPSec checkpoint, both of which are looking at the problem areas that have been reported in the past that were baseline compared against the problem areas that exist now. And if the checkpoint bar is down, that means there's something new for you to look at. If it's up, that means that no, there's no new reporting. You can do a number of interactive things here. For example, you could prompt for a new inspection by simply launching IPLCheck against that particular LPAR that you are working with. Now, one of the major issues to keep in mind when you're working in a browser is that the back button is really quite much your friend. So being able to go back is simply a matter of clicking, and so you can move back and forth from one panel to the next with no difficulty. We can look at the differences that might have been reported for dynamic changes. And in this case, you might recall that our difference was in the LPA list. And we can see here that in a super compare detail that resulted in that difference being reported, that there have been some modules that have been added, been deleted, and there's one module that actually has been added. Now, PF3 back, oh, excuse me, not PF3, back button back. If we want to look at all of those warnings that were produced, we just click on warnings, and we can see a list of all of them. And interestingly enough, we not only see the warning, but we also see the location of that particular warning in the inspection log. So if I click on 392, it'll actually position me directly in the inspection log and highlight for me the specific line in there that it finds to be a problem. Now you notice there's a whole bunch of other highlighting here so that this particular section of the report, 50 lines above the selected line and 50 lines below, also contains some other issues that need to be examined. Off to the right, there's a somewhat unique feature called assisted skills. This is the creation of a dialogue between you and ChatGPT or any other chatbot that you might have available in your environment. And when we do that, we open what's called a modal. That means that this is being displayed by the browser and is not in the 3270 environment at all, where the ICE Direct is running on its own web server, and gives you an understanding, at least from ChatGPT's perspective, of what that particular message actually means. Now, if I go back, I can do several other things. For example, I can look at the whole IPL path. And the inspection of it member by member by member. And so you can see the path here with the NIPS process up at the top, IEA-SIS processing, subsystem processing, again, more IEA-SIS processing, et cetera, et cetera. So JES and VTAM. But while this is interesting, perhaps the more interesting view is to sort this in a way that allows you to see the parmlib member that was last updated in this particular configuration. So I'll do that. And now we can see that the last member that was actually touched in this configuration was the command IF member, the volume it's on, when it was last updated, 6/4, the time, and who did it. Pat Harlow, of course, is our Director of Technical Support. Now, if I want to see what the finding is, I can simply click on the little warning sign. In this case, it's green, so there's nothing wrong with it. Pat did not make a mistake. There are some others that have some mistakes. And we can actually see what that command member contains. But if I go back and I select this one, for example, the BPX or BP PARMS, we can see the detail associated with that and what essentially is wrong. Again, adequate protection seems to be the cornerstone here. But I might be interested in exploring this further. And so what I can do is I can list the data set that this BPX PARM member actually is in, which is, of course, parmlib. So this is the actual member. And from here, I could sort this to find the most recent update to a member in this particular list, if I chose to do it, or I can display the content of the member itself. Now, when I go back, I can also, if I'm a control editor user, I can ask the control editor to give me any history it might contain on those BPX members. And here we have a little donut chart that gives us the understanding that there are 1, 2, 3, 4, 5, 6 different BPX Parm members that are resident in the control journals of the of the control editor. Now, if I click on one of these, then I get additional information about it that breaks it down between whether or not it's a control journal or whether it's in a backup journal. And you can see the blue one is the backup journal and the green one is an event journal. So always have a backup. Number one rule of systems programming. Remember, Bob says it's critically important to always be on your game, and there's lots to be responsible for. Making a backup is always critically important. Now I'm going to just back up again. Now I'm going to show you something that really I find very interesting, which is an analysis that's done here that we call drift. Now, drift is a Gestalt view of the results of an inspection. It not only tells us what has potentially changed in the configuration, but it also lets us know whether or not there are any differences in those dynamic configuration components. Again, I showed you some of this. And then, of course, the configuration itself. If I click on differences in this case, are the findings themselves, excuse me. I'll see additional information about dynamic changes because here, not only will it tell me the module that was added and the modules that were deleted, but it'll also tell me where I can find the, excuse me, the data set that contains that information. And then from here, I can click that and get access to that particular component to determine whether or not I want to perhaps go and make a change to it. One final thing here before we get back to the presentation. In a larger system, this can get not only complex, but the differences between certain dates. For example, when was the log built? When was the last IPL? When was the baseline built? When was the configuration in the baseline built? So 4 really critically important dates to manage the integrity of all of these reports and to do it simultaneously. That happens down here in some management tools that we have, which says show the baseline date aging. By the way, I know these things seem to take some time to accomplish, and that's true. It does. It's analyzing lots and lots of data. Let me go back here. In this case, these analyses that you're looking at are finding their way through almost 85,000 records in order to produce a report that shows those dates relative to each other in roughly 8 seconds. At the bottom of every panel in ICEdirect, you'll find this little performance indicator that breaks down, not only gives you the time, but breaks it down between the time that was spent in ICEdirect, in this case, roughly 60% of the time, against the amount of time that was spent in the network, making sure that this browser displayed this information. So you can see here, there's lots of different ways in which you could do this analysis. The age of the inspection in this case is 0. This thing's running constantly. When it was last IPL'd, 23 days ago. When was the baseline last updated? 3 days ago. And when it was updated, how old was the configuration that it stored in the baseline? And that age is 5. And so this particular, excuse me, this particular image, SAL1, baseline does not contain a current version of the configuration as seen in the most recent inspection. And so you might want to go through a process of actually updating your baseline to make sure that that's true. And of course, you can see all the other ones here. Okay, so 3270, ICE Direct, data exploration. As the amount of data grows, exploring it additionally becomes really critically important. Of course, in order to achieve this functionality, you have to have certain license keys in your NSE PRM member. The two that are critical are the broad scope license authorization. You see this one highlighted here above. And of course, a license key to authorize IPLCheck. That's this one down here, which is also associated with new release analysis. There are other license keys that you would likely find quite helpful through another form of an IPLCheck component, which we refer to as IPL and that would require the Health Checker support license key, as well as another license key for the subsystem inspectors to get all those other checks that are included in the IPSec application. So what's the deal here? The deal is that IPLCheck is easy to use, almost like 1, 2, 3. It offers a lot of flexibility in its licensing so that you can expand the functionality as you need it. It includes embedded AI to show the details of its finding in a fact-based way. It captures dynamic changes versus static changes in the used ParmLab, and it's consumable. Its outputs are consumable by ICE Direct in order to provide you with a better method for exploratory data analysis. Of course, if you're a ZOS strategist and you're using IPLCheck, or if you're using the full function image focus, your view of the world might be quite broad. And being able to examine that broad environment in order to be able to understand issues like, when are my systems being IPL'd? What problems are being encountered? What do my baselines look like? And how old are the configurations in those baselines? Are issues that you should be concerned about to establish the best practices for the integrity not only of ZOS, but for a better understanding of the overall environment that you are responsible for. I want to thank all of you for coming out and sharing your day with us today. It's quite a pleasure and certainly a bit humbling to see all of you out here at the same time. Thank you very much. Sammy, I'll turn it back over to you.
Thank you so much, Paul. And thank you everyone who joined us today. I will be getting in touch with you via email if you left your email address for us to contact you with a link once we get this up on YouTube. Also, if you have any questions that weren't answered, or if you want to start a trial or do a POC of these products, or just learn more about it, feel free to contact us directly. I'm going to drop my email address and phone number into the chat box so you have the information there for you. Also, as I said, keep an eye out for our email. That way you can also share this presentation to anyone who you think may be interested and wasn't able to attend today.